Uh, Basically, I'm doing this because I think it's fun, and it's really cool to be like the mysterious person drinking a white Russian in the dark. So we need to talk about fundamental nature of aging, biological immortality, and basically the reason why humans are the way that they are in general. And that the first thing that we'll start with is the nature of physical continuity. So uh, the way physical continuity works is that a cell will divide into two cells, cell A, B, and C. Cell A is the initial cell, B and C are the daughter cells. Cell A is physically continuous with cell B. Cell A is physically continuous with cell C, but cell B and C are not physically continuous with each other. So this is the core fundamental concept that is required in order to understand the nature of death, because death is the cessation of physical continuity. So, for instance, germline cells maintain physical continuity and are capable of maintaining physical continuity indefinitely, whilst somatic cells are not capable of that. What's a germline cell? What's a somatic cell? A germline cell is any cell that is a precursor to like the sperm and the egg cells or single-celled organisms in the world. Those are all germline cells. It's basically shit. Well, this is a draft anyway, so I can make mistakes. We'll just keep going because I'm tired of restarting. So the germline cells can maintain themselves indefinitely. Somatic cells cannot. The somatic cells are things like the brain, the lungs, the skeleton, the toes, whatever. Okay, fine. What does this mean for aging? Well, what the human species really is a single-celled organism that is surrounded by this intensely complicated multicellular shell. We are the shell. All right, we're the shell. We're a tool that is used by the so-called true life of this world. And it's just really annoying. It's just wow. It's just like holy shit. This is so stupid. Anyway, carrying on. So we're the somatic shell. We are just basically a vessel for the single-celled organisms, which is the real species. What's the purpose of the real species? Well, the real species, every single real species on this planet is basically attempting to live forever. That's what the real purpose of life is. We, the somatic shell of those species, must cope. And our stories about the nature of death being inevitable or acceptance of that, that's all copium. That's all just sour grapes. That's all just sour grapes is a reference to Aesop's fables. You can look it up. It's just a story about a fox who can't get a bunch of grapes, and then he thinks, oh, they're probably sour anyway. Okay. the copium, which is a play on words between cope and opium, which is a reference to a drug that you take to cope with your situation, is a product of us not being currently able to occupy the niche of the germline cell. However, I believe that if we study it well enough and if we understand it, then we'll be able to break through and build technology to replicate whatever it needs to do in order to be biologically immortal for us, for the organism, for the shell. Okay, so let's go into the structure of the whole thing. The structure, the fundamental structure, looks like this. And we start with a fertilized egg, and it's going to divide into about 8 million oocytes. These oocytes are going to attrition 80 to 90% before a human is even born. That's in females. Before a woman's even born, she loses 80 to 90% of her eggs, and that's bizarre. Well, it's not bizarre. It makes a lot of sense. So After that attrition, it keeps attritioning throughout her life. And then there's every single time there's an ovulation event, there's 1,000 eggs that make it out of the ovaries. Of those 1,000, one is able to be fertilized. On the flip side of things, we have the male population. Of the male population, one gets selected. That one creates an event that injects about 300 million sperm into proximity with the egg. Of those, one of them will fertilize the egg. What this system looks like to me is a method of creating a whole bunch of artificial sieves, artificial filters, artificial selection points that allow the human germline cell to create as much progress as it possibly can. What it's trying to do is it's trying to change itself as the best way that it can. It's not trying to maintain similarity. It's not trying to stay the same. It is trying to update itself in order to outcompete all other life forms. All other life forms. Because of this, well, no, I shouldn't say because of this. I should say that it just makes a lot of sense. It explains a lot of things. What germline cells are trying to do, the advanced ones, the ones that undergo meiosis, which is this whole system displayed here. The ones that are trying to undergo meiosis are trying to update themselves as quickly as possible and also as well as they possibly can, which means large numbers of germline cells will die, but physical continuity is maintained from one fertilized egg to the next. So we can switch the diagram up. We have this triangular diagram. Basically, the triangles are this somatic portion of your body, and the germline cell is just the egg portion. The germline maintains physical continuity across generations. So the cell that built you is actually the same cell that built your mother and your mother's mother and your mother's mother's mother, etc., etc. It just goes all the way back. And it's gone back through the beginning of humans, through the beginning of whatever ancestors humans had, to the beginning of possibly like having physical continuity with the origin of life. And by possibly, I mean it probably, because unless life originated multiple times, which is totally possible, whatever origin that spawned the entire lineage that we were part of, it has physical continuity with the beginning of that origin. This is kind of messy, but we'll get through it. It is just a draft. So the origin has continuity with the germline cell, and all of your somatic cells also have reverse continuity with the origin of life. You were spawned from an egg that has had continuity in the past through past germline lineage, the germline lineage to the origin of life. However, the somatic portion of your body is not going to have future continuity. It's not going to be continuous into the future. It's going to end, and the germline cell is going to carry on. Understandably, this sucks for us. What can we do to change it? Well, we figure out what the germline cell is doing, why it's doing it, what rules it has to adhere to in order to maintain biological immortality, and we try to copy those rules and use it for ourselves. And the biggest complaint that most people have with this concept is that we're not single-celled organisms. How could you expect to study single-cell organisms and understand anything and translate that to humans? And I'd say to you this: flight is for the birds. It's we're not born with wings. We don't have light bodies. We don't have hollow bones. Most of our bones are not hollow. Well, isn't that all required for flight? How pointless would it be to study birds to try to figure out how to fly, right? Well, but they're the ones that are flying. Imagine how stupid it is to go around studying like hippopotamuses and elephants and pigs and all sorts of other things in order to figure out how to fly. It's ridiculous. Like you would look at that person and be like, why don't you look at birds and insects and other things that know how to fly and then try to figure out how to build something to fly from that. And they would tell you, no, 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 no. See, we're not birds and we're not insects. So how could it possibly translate over? And it's like, dude, what? Like seriously, like think about that argument, right? Let's at least understand how the successful things are being successful, you know? Like let's know that first. And if some of that stuff doesn't translate, fine, but at least we'll know what it takes to be biologically immortal. Okay, I've run through, I think, the core concepts, the first layer of core concepts. There's a couple other things I wanted to go through. One of this is the damage, this thing I came up with called a damage cascade diagram. So the damage cascade diagram is a way of showing damage propagation through cell, I guess, cell division generations. Basically, you take an initial cell. It's got 0 damage. We'll just assume it has 0 damage. You age it. It's got a damage level of 1. Arbitrary units, completely arbitrary. That cell divides, and you can have a number of different motifs, another number of different rules, but we'll say for the sake of this that this is some kind of a rod bacteria, and there's an old pole and a new pole, and we'll go with the theory that all the damage gets pushed to one side, which by the way is a weird theory because it makes sense for the outside of the cell, but what about the cytoplasm and all the internals, right? How would you segregate the damage? And if it could be segregated, shouldn't we learn how it gets segregated in order to like replicate that technology? Because I feel like that would be pretty important. Anyway, let's say the damage just gets segregated. Now when it divides, it creates 2 cells. One of the cells has a damage level of 1. The other cell is brand new. And you just keep repeating the process, right? Those cells get aged. Now you've got a cell of 1 and 2 damage level. Those cells divide. You've got 2 clean cells, 1 cell with 1 cell with 2 level of damage. And you can map this out. And at some point, arbitrary threshold of like maybe 20 or something, there's too much damage and the cell cannot divide. And you can figure out a growth curve for this, and you can figure out if this is actually what's happening and whether the rules that you're projecting onto the cell make sense. Okay. Then you kind of zoom out and you say, okay, well, after 20 generations, I want to know how many cells are just as viable as the initial starting cell. I want to know how many cells are capable of just being the same as that initial starting cell in terms of not having any damage. Okay, well, we can create something called what I call a viability cone, or cone of viability, as you will. Yeah, okay. The internal part of the cone is the number of germ cells that are just as viable as the starting germ cell. The outer portion are all the sort of the damaged ones or the ones that are attritioning. And it's going to be different for all sorts of different species, right? So for humans, it looks like a line down the center of the cone, but for other species, it's probably going to be much wider. And that's because if other species, like single-celled organisms, tried to do what humans are doing, human germline cells are doing, they would not survive in the wild. They just wouldn't. There's no way that they would survive in the wild. They get destroyed by too many random things to be doing this kind of stuff. So their rates, their layers of what am I trying to say here? Their viability cone is much larger. This is important for arguments that get made for how to use germline mechanisms to do regeneration, because if you make the argument that the human germline requires 8 million replicants in order to get just a handful of them to be viable, that's going to be really hard to use for the somatic portion of the body. But that actually is not, it's not happening like that because of survival reasons. It's happening like that because of competition reasons. So that's fine. Okay. I think that covers everything. I think this is a pretty good first draft. I think this is pretty fun. I need a better cup. I need like a wide based cup. That'll change things. That'll really change things. No, so and then apart from that, let's see here. There's ECM. That's a completely independent problem from the germline problem. There's a couple other independent problems. I think that diet and microbiome don't have much of an impact in a relative scale. Like they probably have a big impact in terms of like maybe you might be able to like get 50 years out of a person or something like that by like optimizing microbiome and diet and all that kind of stuff. Maybe you can get like an extra, maybe you can get to like 150 or something like that, or 170 maybe, but it's doubtful. You know, I think that what it really is an accelerant. So diet and microbiome seem to be very closely tied together. And by diet, I mean calorie restriction, protein restriction, that kind of stuff. I think that that's very closely tied together. And I think that is only an accelerant for the other mechanisms, but it's not a root cause in and of itself. So we've got that. Yeah, very cool. Okay. I like this. I just hope that I can do something. I hope that I can be in a position to actually get something done. It's gonna be very difficult. It's gonna take a while, and it's not gonna, you know, it's not gonna fit to any kind of VC's timetable or you know, whatever. But there's something here. Okay. Germline, nature's okay with biological immortality. All right, it is. It is. Nature's fine with that fact. It doesn't have a problem with things being biologically immortal. It just has a problem with us being biologically immortal, the shell that surrounds the germline. And, you know, nature doesn't have a problem with flight. It just had a problem with us flying because we don't have wings, we don't have the right body structure, etc. But by God, we we defied nature and we just built a thing that flies. And we built things that go underwater and stay underwater longer than any other mammal. We've stayed up in the air longer than any other organism. We've gone into space. We've done things that nature clearly does not approve of. And it's fine. It's fine. And I think that this can happen. It's not, you know, there's no law that says, in fact, the de facto standard of most of the life on this planet is to live indefinitely. That's just how things are. That's just everything else. It just feels like most of the life on this planet is part of this big party, right? They're having this big party and we're not invited. And it would be nice to just be at least in the same room as everything else, you know, just at least have a chance of just participating in that layer of reality. Because there are a lot of organisms on this planet that are participating in that layer of reality. And we're sitting here, you know, trying to cope with our situation, thinking, oh, well, nothing lives forever. Dude, tons of things live forever. Fucking tons of things, okay? There's a lot of things that are living forever. And their whole goal is to live forever. And they're fine with it. And they just go about their day and they're just like, yeah, that's what I'm doing with my life, is living forever. And we, the short-lived but extremely capable entities that we are, are just down. I mean, just why? Like, anyway, so I think we can get there. I think we can get there a lot faster than people think that we can, or at least the pessimists think that we can. I think it's going to take way longer than the optimists think that it can. And the only thing that we can really do is just try our best. And, that's really all that can be hoped for. All right. That's a good first draft.